Okay, looking at the My iMaths exercise 3D trigonometry. Question 1, first part of that says, in this cuboid, work out the angle AGD. So that involves a pink triangle inside the cuboid. So what I'm going to start by doing is thinking about the base of that cuboid. So I'll just draw a rectangle for that. C, D, G, H, and then the diagonal DG of that rectangle is also the base of the pink triangle in the diagram. And we've got enough information to figure that out because DH is 3.9, we can see that from the question. GH is 6.5, so they're just the sides of the cuboid. And then we've got a right angle in there, and we've just got to work out the hypotenuse of a right angle triangle DGH. So DG squared equals 6.5 squared plus 3.9 squared. So DG itself is just going to be the square root of 6.5 squared plus 3.9 squared. I'm just going to simplify that a bit on the Desmos calculator. So I'll just clear what I had before. I'm not going to actually figure out the square root of it. I'm just going to simplify the bit that's inside the square root. So the 6.5 squared plus the 3.9 squared is 57.46. So DG is the square root of 57.46. I'm now going to look at the pink triangle. So in the pink triangle, we've got three sides, obviously. And that pink triangle is right angled because it's something that's horizontal along the ground against something that's vertical. We can see from the question that the height of that is 4.2. And then we just worked out that the base of it, DG, was the square root of 57.46. So let's just label that. We've got G over there, D at the right angle, and then A at the top. So AD is 4.2, the height of the cuboid. DG is the diagonal of the base, which is the square root of 57.46. And we have to work out the angle AGD. So the angle that's just in there at G, that's the angle we've got to work out. Well, in relation to that angle, the 4.2 is the opposite, and the square root of 57.46 is the adjacent. When we've got opposite and adjacent, we use tan. So generally speaking, tan equals opposite over adjacent. And in this particular case, the tan of the angle AGD that we're trying to figure out equals the 4.2 divided by the square root of 57.46. So that's something, well, first of all, let's just inverse tan that. So the angle itself must be the inverse tan, or I like to call it arctan, you'll see tan with a little -1 on various calculators. So the arctan of 4.2 over the square root of 57.46 gives you the angle itself, and that is something I can just put into the Desmos calculator. So I'll go function and then tan with a little -1 for inverse tan. And then I want a fraction there, so back to the main menu, make a fraction, and then I want 4.22, don't know why it's done 4.23, 4.2 over the square root of, so let's make a square root, 57.46. So that's giving me 28.98 degrees, so equals 29 degrees to the nearest degree. So I will fill that in on the answer box on iMaths. 29. Okay, moving on to the next question. It says, in this triangular prism, work out the length BF. And we've got various other lengths. So there's nothing here involving angles. So we don't need to involve trigonometry on this one. We can just do it all from Pythagoras, in fact. And I'm going to look at the base of that shape, first of all. So we've got a kind of rectangular base, and it's 6.1 that way, and it's 5.4 that way. And it's got a diagonal across it, which is the bottom of the triangle, CF, and it's right angled. So if I just think about the right angled triangle CEF, so it's 5.4 and 6.1, the two shorter sides, and then the longest side, the hypotenuse, is CF. So I can use Pythagoras to figure out what CF is. So CF squared equals 5.4 squared plus 6.1 squared. CF squared equals, let's just work out what that is. Onto Desmos again. Clear what I had before. 5.4 squared plus 6.1 squared, 66.37. So CF itself is the square root of 66.37, which for the moment I will just leave like that and not try and evaluate it as a decimal, because that will lead me to having to round it off at some point. But if I just leave it like that, it's fully accurate. Okay, so now thinking about the blue triangle. The blue triangle is CF at the base and B up there. It's right angled because it's something that's perfectly horizontal along the ground in CF against something that's perfectly vertical. So they're perpendicular to each other. It's right angled. We've just figured out that CF is the square root of 66.37, and we know that BC is the height of the whole thing given in the question as 5.2. So we have to work out the length BF, and again it's just Pythagoras working out the longest side in a right angled triangle. So BF squared equals 5.2 squared plus this side, the square root of 66.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . 36.37 . squared. Okay, well, the square root of 66.37 squared is just 66.37. They cancel each other out. So that's 5.2 squared plus just 66.37. And then BF itself must then be the square root of all of that. The square root of 5.2 squared plus 66.37 not squared. So I'll get that onto the calculator, clear what I had before. So I want the square root of 5.2 squared plus 66.37. And that gives me 9.664. It says give your answer to 1 decimal place or better. So to 1 decimal place, that's 9.7. 9.7 to 1 decimal place. Let's put that in the answer box. 9.7. Okay, let's go on to the last question on that page, which involves a pyramid with a square base. So I'm just going to look at the base of that pyramid. So it's A, B, C, D. So it's 6.6 both sides, because we're told that it's a square-based pyramid. And because it's a square-based pyramid, when we make those diagonals meeting at E, they're all going to meet at 90 degrees as well. So it would be good if I could figure out what each of these 4 short lengths are, because one of those is the base of the orange triangle that we're trying to figure out something in. So if I just call each of these, if we call them all X, and then if I just look at one of these triangles, that one for example, it's right angled. It's got 2 sides that are X and a longest side that's 6.6. So X squared plus another X squared makes 6.6 squared. That's Pythagoras. In other words, 2X squared equals 6.6 squared. X squared on its own is going to be 6.6 squared divided by 2. And then X itself is going to be the square root of that. So the square root of 6.6 squared divided by 2 is what X is. I will evaluate that as a decimal because that's quite a complicated expression to have to write within another expression at the next stage of calculation. So the square root of 6.6 squared divided by 2 comes to 4.6669. I'm going to round that to 4.667 to 3 decimal places. And hopefully that will be enough accuracy not to affect my accuracy in the subsequent stages. Okay, so now looking at the orange triangle, which I'm just drawing now. So the orange triangle is A, E, V. We're told in the question that the slant lengths of those pyramids are 8.7 centimeters. And we've just worked out that from E to A, so that was one of those X's, is 4.667 to 3 decimal places. The angle we want is AVE, so that's the angle at the top, and in relation to that angle AVE at the top, the 4.667 is the opposite side, and then the 8.7, well, that's just the hypotenuse of the triangle, because it's opposite the right angle. So we have got opposite and hypotenuse, and generally speaking, when we've got opposite and hypotenuse, that's sine. Sine equals opposite over hypotenuse. So on this particular occasion, we've got that the sine of the angle that we're trying to figure out, AVE, equals the opposite, which is 4.667, over the hypotenuse, which is 8.7. So the angle AVE itself is going to be the inverse sine of that, or I like to call it arc sine. Arc sine of 4.667 divided by 8.7. And then I can punch that into the Desmos calculator, so I'll clear everything I had. So I need to go onto the function section. So it's a little sine with a -1. That's how they represent inverse sine or arc sine. Back to the main page of that. Make a fraction. The inverse sine of 4.667 divided by 8.7. Then it gives us 32.441 something, which to the nearest degree is 32, because we were asked in the question for this to the nearest degree. 32 to the nearest degree. Let's just put that in the answer box, 32, and get it to mark it. And there we are, 9 out of 9 for that one.